Hello, I am Ben Havens and I am here to teach you about compounding periods. Now, a compounding period is the time frame that elapses between which an investment is made and the point at which that investment, the interest on that investment, is compounded. So the scenario at hand is Mr. Smith recognizes a depreciation in the value of his marriage. He predicts that major implications will arise if he does not do anything within the next 2 years. Now, he decides to put away a portion of his paycheck each month at 2% interest rate compounded monthly in order to purchase a $10,000 diamond necklace for Mrs. Smith before she files for divorce. Now, how much does Mr. Smith have to put away each month in order to save his marriage? So we'll have a cost diagram. Each month, starting at month 1, again at month 2, again at month 3, etc., etc. He will pay a value of P. Now that'll go all the way up from 1 month, 2 month, 3 month, all the way up to the 24th month, or 2 years. Now in that same month, he will invest in the $10,000 diamond necklace, which will be a negative value of negative 10K. Now, in order to ensure that the monthly payments he invests will turn out to be equivalent to the $10,000 he needs, we compare them in present value. So we'll take the equation for the present value of this one-time future payment, which we will call A, and we will take present value of A will be equal to that A value times 1 over 1 plus the interest rate, all to the number of compounding periods. Now, a slightly more complex equation for calculating the present value of all the P values will be PV sub P is equal to that unknown P value times quantity 1 plus R to the T minus 1, all over the interest rate times 1 plus R again to the T. Now we know, given values from the equation, we know that A is equal to $10,000. We know that R is the interest rate, but we convert it from 2% to the decimal, 0.02. And then we know T. Now T is 2 years, but being that it's a monthly compound, it's just more convenient to leave everything consistent in a monthly basis, so the 2 years will be equal to T, where T will equal 24 months. Now we input these values and we get a negative 10K times 1 over 1.02, all to the 24. That value is a negative $6,217.21. Now if we do the same here, we leave the unknown value P, and then we have the equation 1.02 to the 24 minus 1, all over 0.02 times 1.02, again to the 24. This value is equal to the unknown P value times 18.9139. Now we take these two values, sum them together, it means that one's negative, one's positive, and set them equal to 0 to ensure that the two values are equivalent. So we have PV sub A plus PV sub P is equal to 0. We input the two values and we have a negative $6,217.21 plus the unknown value P times 18.9139, all is equal to 0, which, doing the simple algebra, we get P is equal to $328.71, which is the amount of money Mr. Smith needs to invest in each month in order to save his marriage. Thank you.